Recording, okay. So, obviously everybody can see the screen right now. It's just a reminder that next Tuesday is our day for post-assessment testing. So we're all going to meet up in the computer lab next to the Excel, which is right next to the classroom anyway. So if anybody feels like showing up, we'll be there waiting for you. And if you get lost, I'll be wandering into the hallway every little while to see if anybody looks confused. If you can't make it, shoot me and Elizabeth an email, and we'll make sure that you can take it remotely. Because taking it at home is an option if need be. So, 1 second, somebody's having trouble accessing the class through Zoom. So I'm going to go ahead and pull that up. Sorry, guys, just replying to an email for a student. Someone who doesn't normally attend online is attending online. Well, trying to. That's actually the problem. Leave that open. We'll start in just a minute, guys. Somebody's having trouble accessing the Zoom meeting. So once I have enough people, I'll be good to go. And then we'll be at half the class, which will be great. I'm cool with that. That's exciting. That's only slightly less than I had the other day. There's got to be a way to log in here without getting 3 security alert emails. Every time. Every time. Okay, well, Ben's impatient. So, yeah, if you can, meet in the computer lab over there. Otherwise, we will be connecting through Zoom. Anybody who isn't doing testing on Tuesday will be doing essential ed lessons. So if you need any particular help on anything on there or any of the lessons that we've done so far, it's going to be a good time for it. You can get some one-on-one help. We got this.
So is this for everybody or everybody that has their 60 hours?
I'm very hazy about the details there. I was told that it's anybody that's over 50 hours in overall instructional support. So like across the essential ed, across being in class, etc. How that stands, I don't know where everybody stands. I think a large chunk of everybody can actually do this, but I don't have the exact figures on that. But at the very least, I think last time I taught the class over in the fall, I didn't have a problem of anybody being told that they couldn't test. So we'll make it work. So today, it's kind of funny. We're literally just reviewing the slope of a line because last time I realized we did so much review that I covered like 3 slides, 3 or 4 slides of new stuff last time. Graphing lines takes a minute. It takes a minute for people to pick up on. That's fine. Today we are definitely getting to the slope-intercept form of a line and how to graph with it. Then there's actually a method of finding the equation of a line if you're just given some information about it. So we'll be able to do that. And if we manage to get that far, we'll start looking at the 2-dimensional geometry stuff, which is, it's pretty basic stuff. It's areas and perimeters of rectangles and triangles and circles. That's, I think, all of it. And then there's a bunch of weird stuff with angles, and that's probably my least favorite thing. It's just a lot to cover. It's not hard. You can kind of eyeball it and know how everything works. But yeah, all the angle stuff, I don't even know if we're going to get to it. We'll find out. So I figured, just like last time, since we don't have a whole lot to review, I'll just review roughly the same slides, tweak them a little bit. So if you recall, last time we covered what the slope was. It's basically just how it angles away from the horizontal line of the x-axis. So every time you have to find the slope, you generally have 2 points that are anywhere on the line, doesn't matter where, and you just call one of them x1, y1, and the other one x2, y2. You take those pieces, you throw them at the formula, and you clean it up, and you're done. That's it. It's really not bad. And I do have it on there. Slope can be thought of as rise over run, because the change in y in the numerator is the rise between points, and the change in, I can type, the change in x, that's, okay, don't blindly click a button on a keyboard. There we go. The change in x in the denominator is the run between points. So really, you're just kind of measuring the difference between the points and getting a figure off of it. So if you recall, this was our example. So you have the example of y equals 2x plus 1. And I had actually had the points -2, -3, and 2, 5. That was actually the first one we did. This was actually an example of the first one we did as graphing by plotting points. So that's where those points came from. So it doesn't actually matter which points you pick, as long as they're on your line. So you follow through the equation. You can see there's step 1, plugging everything in. Step 2, cleaning up the signs. Step 3 is 8/4. So you got it cleaned up. And then if it reduces from there, which it does, you reduce. If it doesn't reduce, then you're done. So it's not bad. And if you look at that example, the equation is y equals 2x plus 1. That is perfectly in that formula that we learned last time, the slope-intercept formula, which we will go into far more detail with today. But that actually is telling you that the thing on the x value there, the thing multiplied onto the x, is your slope. So if we had already known that before having to do any of this work, we would be able to look at y equals 2x plus 1. And if somebody asked me what the slope was, I'd be able to just say, oh, it's 2. No problem. Now, the other part, the plus 1, we'll get to that today, after some examples, of course. And this is the slope-intercept form of the straight line that I was referring to. So it's always y equals mx plus b. The y and the x are just any point on the line. Just Or another way to look at it is they're every point on the line. As long as they're variables, they vary. M is the slope, and B is actually the point where the equation intercepts the y-axis. If you think about it, the y-axis is where x is 0, right? That's kind of like right dead center of your graph. And when x is 0, it's not going left or right anywhere. Well, if x was 0, then you would have m times nothing. So that means that whenever you're on the intercept, the only thing left in your equation is the plus b. That'll make more sense when we start working these out, but you'll be able to see it a lot clearer. Why did I write so many examples? We'll just do a couple of these. We're going to be doing a lot of finding the slope and other things anyway. So I'll also write down number 1 first. So for number 1, we have the point -15.3 and the point 24. And remember, we're finding the slope, which is given by the formula y2 minus y1 over x2 minus x1. I say it over and over and over again, so it hopefully gets stuck in your head. And if it gets stuck in your head, like it is with me, you'll never lose it. I have written that probably well into the 4 digits times. I could find a slope in my sleep the amount of times I've done slope. My God, lots of slopes. So in order to do this problem, we're going to have m equals. Now, if you're getting the feel for it, you can just jump right into taking the points from what you're given and throw them at the formula. If you're not, no shame in that. We can label them. Doesn't matter which one is x1, y1 and which one is x2, y2. If I flip these guys around and had the first one as x2, y2, it'd work out exactly the same. So based on that, you can then plug it into the formula just like that. We have y2 minus y1 on top. So we'll have 4 minus 3 on top. Over x2 minus x1. So that would be 20 minus a -15. Always be careful when you're subtracting a negative. I like to put it in parentheses like that because you can easily make the mistake of losing that sign. And when you do it, when it counts on a test or something and you look at it, you're going to be like, my God, that guy told me 100 times to watch that and I still did it. And guess what? I still do it too. It is probably one of the more common mistakes you'll make in math. All you can do is learn to be a little more careful. Okay, so we can clean this up now. Now, whenever we subtract a negative, this thing's going to end up being a plus. So this will be 4 minus 3 on top, 1. On the bottom, we have 20 plus 15. That's 35. This is the point where I said, if you can reduce, you do. Well, I'm pretty sure 1 over 35 isn't going to be reducing anywhere. Well, that just means we're done. That's the slope. That's all we got to do. All you got to do is label your points if you need to. You can even not do that if you're good with it and throw it at the formula. So worst case scenario, as long as you know the formula, you're good. And not 100% if that's something you're given. Let me switch over to my Google Drive here. So did I actually? No, I didn't. Okay. Should have, yeah. This is the formula sheet given for whenever you take the high set test. Does not look like they give you the formula for the slope. They give you all the area stuff for the shapes and everything. So if you have anything relating to slope on this test, you're gonna want to have this equation memorized, which might make some people absolutely terrified. So just think of it as this is the change in Y, this is the change in X. Change in horizontal in the vertical over change in horizontal. Change in up over change in side, whatever sticks it in your head, go with it. Okay, let's do a couple more. I don't know how many to do at this point. I don't know why I decided this one would be a good idea, so this is the one I'm jumping at. Number 4, we have a 1, 1 and 500, 500. I think I just did that because a lot of people get intimidated by large numbers. And I just did this so you guys would see, hey, doesn't matter. And this could be X1, Y1 again, just for the sake of bouncing around. I'm going to call it X2, Y2, which makes this X1, Y1. Doesn't matter which is which. So our slope will be given as Y2 minus Y1. So 1 minus 500 over X2 minus X1. That's also 1 minus 500. Okay. So I have negative 499 over a negative 499. It might come as a shock to you, but that reduces. The negatives cancel, the numbers cancel, everything cancels down to the point where how many times does 499 go into 499? There we go. And I felt like saying it that way because sometimes I get people who get a little confused and they'll see this and they'll cancel it out and it'll poof into oblivion and they'll write a 0. And that happens. That's another common mistake. So worst case scenario, you can always cancel by saying, how many times does this go into that? Break it down that way and you will be good. Let's see. Are we feeling good about finding slopes between points, or do we need to see a few more of these ones? Everyone is quiet. Everybody's feeling good? Oh. Few more, please. Thank you for responding. I genuinely appreciate it more than you know. Okay. Well, if I'm doing a few more, let's bounce around. I did 1, I did 4. Let's do 2. Because that is confusing to look at. I knew a guy back in the day who would do his math homework in the order in which he thought it was easiest to hardest. And the numbers were just everywhere. And the teacher hated him for it. But also, they don't really, they're not too nice teachers these days. So he just kind of dealt with it and just crabbed about it a lot. Things was messed up. I kind of respected it at the time because, I was also a jerk kid. But I don't know. I'd go back in time and kick my own butt, and I'd kick his butt. And it'd be easier for me now because, children. I'm pretty weak, but I probably could take a kid in a fight. Things I shouldn't say out loud while teaching a math class in a recorded Zoom call that I'm going to place on YouTube myself. Yeah, nobody cares. Okay, so same idea. Got some points, label them x1, y1, x2, y2. Again, doesn't matter which is which. You can see I'm just kind of alternating for funsies. And we're going to plug it into the equation. Where's the equation? All the way up here on top. That's okay. So our m, our slope, is going to be y2 minus y1. So -3 minus 3 over x2 minus x1. Same thing happened on this one that did on the first one. I'm subtracting a negative number. So you have to make sure you put that in parentheses so you do not lose your sign. Don't lose the sign. Okay. Let's clean it up a little bit. -3 minus 3, that's going to be a -6. Over. This is going to turn into a plus. So it'll be 3 plus 7. Because who wants to think about taking away a negative? Come on. So 3 plus 7, that's a 10. Now you have the slope, but it can be reduced a little, right? We got an even number on top and an even number on bottom, which means that 2 goes into both. 2 goes into the 6 3 times, and 2 goes into 10 5 times. Beautiful. Look at that. So we get -3/5. Now, this being our first one that has the answer with a negative, I do want to point out something, and this is actually going to be very relevant to the next stuff we cover. I do want to point out that this negative makes this whole term negative. And because of that, it's actually equivalent to any situation where there's a negative in these numbers in this way. So this is perfectly equivalent to a negative outside of a 3/5. That's exactly the same. And it actually is the same as 3 being over a -5. If this is negative at all, the whole thing is negative or part of it is negative, that negative can travel where it needs to. Now, those can be proven by doing a little bit of algebra on each one, but just take my word for it. You can have a negative on the top or on the outside or on the bottom. It's all the same either way. They're equivalent. Why do I stress this? Because we're going to be using that. We're going to be using that. Which one's the actual answer? Doesn't matter. First one you got, second one you got if you feel like it's prettier. Doesn't matter. They're all the same. If it's equivalent, that means it's equal. Doesn't matter. All right, let's do, yeah, hell, let's just do them all. They're quick enough, right? Number 3 is 1/8 and 14/2. Okay. Same thing, but let's not label them this time. I mean, if you're following along with a pencil and paper at home, you could certainly can just to spite me. Whatever, I'm not going to hold a grudge. But if we know it's the difference between y's on top and the difference between x's on the bottom, I can just as easily say, oh, okay, so the top is going to be the y's subtracted from each other. So I could, no, let's say I started with this one. So I did 8 minus 2. Do an 8 minus 2 there, right? Okay, since I started with this point, I better start with this point down here. The bottom is the difference in x's. So it'll be this x minus that x. So 1 minus 14. Okay. Clean it up a little bit. 8 minus 2, that's a 6. 1 minus 14, that's a negative 13. That doesn't reduce at all, right? That's our answer. Now, compared to how much work I've actually put in to show you guys each of the steps as we go, in practice, if you're doing it yourself, you got the formulas memorized, you've done this a bunch of different times, this is how much room that's going to take on paper. Just this a little bit, not a whole lot. So once you get used to these, they go fast. One more left. You can tell I got really lazy with this problem. So we got 12 and negative 34, and then 56 with a negative 78. 1, 2, 3, 4, 5, 6, 7, 8. Effort. It's a beautiful problem. I'm actually kind of curious what the answer is. Okay. Let's do it the same way. Let's not worry about labeling. So it was the difference in y's over the difference in x's, right? So I could do either negative 78 minus negative 34, or I could do negative 34 minus negative 78. It'll work out exactly the same way. Just you end up with a different sign depending on which direction you go, but it ends up canceling out either way. So the answer, if I do this, I've said this over and over, I haven't actually shown it. If I do it either way, it's going to work out the same. And I keep saying that, and I haven't actually shown it yet. So why don't I show it? So we got the differences in y's over the differences in x's. But I'm also going to end up doing that starting with the other point down here. Just for an example. Just so you guys can see that it works out. Doesn't matter which point you start with, it'll work out nicely. So this ends up being a plus. So we end up with a negative 34 plus 78. That ends up being a 44. And then 12 minus 56, that ends up being a negative 44. I didn't know what would happen if I picked all the digits in a row and just made them work. But evidently, how many times does 44 go into 44? 1, yeah. So we got a negative 1. It's kind of funky. I like it. Now, if I did the same thing the other way around, if I had started with the second point instead of the first point, I would have a negative 78 plus a 34 on top. That would end up giving me a negative 44 up here. And then down here, I'd have 56 minus 12. That ends up giving me a positive 44. So it's the same answer. So that's the difference if you pick one point versus the other point. The signs kind of end up negating. What was once positive turns negative, and what was once negative turns positive. But it ends up working out exactly the same way because we got one negative overall, so the whole thing's just a negative number. So anytime you're doing these problems, you don't have to stress which point you're going to start with. You just pick one and you roll with it. It's going to work out. You might say, hey, Ben, which one would you choose? And I would say, I would spend far too long justifying which one to choose. These are pretty quick. Just pick one and roll with it. Doesn't matter. Just blindly pick it. Okay. Now we got the other side of the examples to deal with. I got a little bit more interesting examples than last time. Only a little bit. They're not wildly impressive, but this is going to touch on some concepts that I didn't cover last class when I was covering the slope. So this is going to be very, very convenient. Very convenient. Cool. So got them all written down. So the instructions are exactly the same. They're find the slope, right? Well, on all of these, I made sure that there were none of them that I could just very quickly eyeball. Well, one of them I can, but you can't. That's the point of this, right? So in order for us to get to the point where we can look at our equation and say, yeah, that's the slope, we need to solve it for y equals, because our equation is y equals mx plus b, or our formula, whichever word you feel like throwing at it. And when it comes to finding the slope, well, it's the m. So whatever we got, it's right there. That's it. So every one of these, we're going to have to solve for y equals. Which ain't bad, not bad. So with this first one, I'm going to get the term with the y alone first. So I'm going to subtract the 2x. I'm going to have 3y is equal to a negative 2x plus 6. And again, just like last class, I put the term with the x first because in our formula, the term with the x goes first. So I'm trying to get it to look closer to our formula with every step. Now our next step is this 3, getting rid of that. So when you divide one side by 3, you have to divide the entire other side by 3. And that ends up dividing every individual term by 3, like that. Okay. Well, we end up with y is equal to negative 2/3 x plus 2, right? Well, we've solved it for y, which is our aim. And what's the slope? I'm gonna make somebody reply to me. I don't care who. I'm just gonna sit here all crabby and angry. Man, nobody talks. Man, this is a really bad penguin. Man. Anybody? Anybody? Oh, I see it. I see it. I see it. Nope, you are incorrect. It is the other number. Yeah. So it's always the one that's attached to the x. So it's going to be the negative 2/3 on this one. The 2 is actually part of, that would be represented by the b in the formula. That is our y-intercept. That's going to be important for us to know when we start graphing with these formulas. Because literally all we're going to be graphing from is knowing those two pieces of information. So in this one, y equals negative 2/3 x plus 2. Negative 2/3 is the slope. The 2 is the y-intercept. Cool. All right. Next up, the exact same thing with roughly the exact same amount of steps. I feel like I should have changed that one up a little bit. Oh, Ben, you lovable goofball. All right. What? Huh? Yeah, that thing. Yeah. Yeah, we're gonna number 7 this. So we're gonna subtract off the 8x from both sides. Now we have a negative 2y is equal to negative 8x plus 4. Okay. Now, just like that last one, I have to divide every term by the thing that's on the y. In this case, it's a negative 2. So what ends up happening is all the signs over here, because this was a negative and this was a positive, since I'm dividing by a negative number, all those kind of flip, right? This guy is a negative divided by a negative, so it ends up being a positive. 8 divided by 2 is a 4. So we have 4x. And then this guy, we had a positive divided by a negative. That'll give us a negative. 4 divided by 2, 2. Okay. So if I look at this and I say, hey, what's the slope? There it is. Found it. Cool. Now the next couple are kind of tricky. Intentionally. I did that entirely intentionally. This next one, x equals 6y. I did this way because I started writing out a problem and I was like, nah, if I just stop at the 6y, that's going to make everybody stare at it for a second. It's like, what do you do? How do you make this fit that formula, right? Well, interestingly enough, you do the exact same thing. We are just like all these other problems, we're trying to solve for y, right? But this one actually touches on an interesting concept when it comes to the y-intercept, and I'll show you in a second. So the idea is that in order to solve for y, I would have to divide by 6, right? Well, that doesn't quite look like our formula, x over 6. Doesn't quite look like y equals mx plus b, right? So one trick is that you can always, anytime you have a variable on top, you can always pull it out if it's just one variable that's multiplied onto whatever's already there, even if it's the only thing. Because think about it, how many of those x's do I have right now? 1. So if I had little phantom 1 right here, well, if I pull that x out, what's left there? That 1. Now, I'm able to recognize that this is the thing on the x, which makes this my slope. So my slope is 1/6. But what I wanted to point out is what's the y-intercept. So if I take this concept over here, let's break that over a little bit. We have the y equals 1/6 x. And we're fitting this to look like that formula that we have, right? Y equals mx plus b. We've already determined that the 1/6 is our mx, right? It's our m. But what happened to the b? There's nothing here. There's something there on all my other problems, right? So is this actually in this format? Yes. Yes, it is. Because if I have nothing there, what number is nothing? 0. So you can kind of look at this as the y-intercept being 0. If I don't got anything there, I don't got anything there, right? Which means it crosses at 0. This one would cross the intercept or the y-axis at -2. This one up here, that one crosses the y-axis at +2. So that's just useful to have. But let's look at these next couple. What the hell is going on here? Neither one of them fits our formula, right? Particularly number 10. Neither one of them does. But that's why I wanted to go through this whole concept with the zeros. Because if I have y = 6, and I'm trying to fit that to y = mx plus b, this 6 is a constant number, right? Doesn't have a variable on it. So that can't be our slope. If I had to say it was anything in our formula, it would be the b, right? So if I was fitting this to my formula, I would know that I'd have a +6, but where the hell is the slope? Well, it's the same thing that happens up here. If I don't have it, then I don't have it. It would have been 0, right? So that's actually an interesting scenario on these types of problems. Because if I have a y equals anything constant, I should write. My slope, my m, is always going to be 0. Always going to be 0. Now, let's say you don't trust me on that. You're like, Ben, you're kind of like half here all the time anyway. You're kind of rambling. I don't trust what you're saying. You seem like you're kind of nuts. I don't know how you ended up in charge of this class. Yeah, me neither. But let's say that I wanted to prove it. I want to prove this has a 0 slope. Well, let's look at our y = 6. And yes, I'm going to cram this all in a small area on my paper. Do I regret this? Yes, I do. I kind of wish I gave myself more room for this lesson. But let's say I was plotting some points, right? Random points out of the blue. I could do my usual, like before, I would do -1, 0, and 1, right? Well, the thing is, our equation is just y = a number, right? So giving an x value to something isn't going to matter because I have nowhere I'm plugging it in. So if I said that x was -1 and I asked myself, hey, what is y at that point? Well, y is constant. Y is 6. Okay, well, that means that when x is -1, y is 6. Okay, what about when x is 0? Y is still 6. When x is 1, y is always 6. Well, we got some points. Let's graph those real quick and see what the heck I'm looking at. Okay, -1, 6, 0, 6, 1, 6. Well, that's just a flat line. It's a horizontal line. And if you can't keep this in mind all the time, you are fine. Do not freak out. I sincerely doubt this is going to be something that is on your test. I just want you guys to understand it a little better. when I have any y equals, it ends up with a horizontal line. And think about what slope is. Slope is rise over run. I got a flat line. What's my rise? Nothing. It ain't going anywhere. It's flat. What's my run? Whatever. It depends on the points I'm picking, right? Anything. It could be anything. It could be anything. It could be nothing. Between here and here, it's 2. It'd be 0 over 2. Between here and here, it'd be 1. It'd be 0 over 1. I mean, I could do x is 500 and y is 6, and it'd be 0 over 500. Doesn't matter what you got on the bottom. If you have a 0 on top, it's just going to break down to a 0 every single time. So anytime you have a y equals, you always end up with a horizontal line, because that means that y is always going to be this number regardless of the x. And that means that you have a 0 slope, because we have our rise is nothing, our run is whatever. Now, that gives us a little bit of a hint of what's going to happen on number 10, right? Because, well, if I just said y equals is always going to give us a horizontal line, you probably guess what x equals is going to do. X equals always gives us a vertical line. Let's just jump randomly to a graph. I don't need to pick any particular points. If y was what is this? 6? If y was 6, what's x? X is 1. If y is 2, what's x? Still 1. X is always 1, right? So you end up with as many points as you want, doesn't really matter, but you always end up with a vertical line. Now, you might notice there is no way for me to magically make this equation conform to our y equals mx plus b, right? Not really a way of doing that. I would have 0 for the y at that point. It can be done, it's just going to look weird. It's going to be harder to decipher. But either way, the slope's going to be weird, right? So let's think about what the slope is on something like this. Slope is always rise over run. It's always the difference in y values on top and the difference in x values on bottom, right? We just did a bunch of problems like that. Difference in y's, difference in x's. So in practice, what does that tell us on a vertical line? Well, between any 2 points, what's the rise? Whatever you want it to be. Because it's a vertical line, it's going up forever. It's going down forever. So if I pick negative 500 and positive 500, the rise would be 1,000. And I could keep picking random points like that. So what I'm going to do, just as a placeholder, I'm going to say my rise is infinity. It's everything. It's just going to keep going. It's whatever you want it to be. But what's our run? That's the important bit. Over here on the horizontal lines, it didn't really matter what the run was because the rise ended up being 0. Well, here, the rise doesn't matter because the run, we're not going left or right at all. It's not moving. 0. Now, this doesn't end up giving us an answer of 0 because an answer of 0 is 0 over something. But what ends up when you have, what if you have 1 out of nothing? What if I have $5 out of nothing bucks? You're conjuring nothing out of or something out of nothing, right? That doesn't work. So this actually can't happen. You can never divide by 0. You can't split anything apart 0 times. It blows up. So that ends up being something we would call undefined. It doesn't exist. It can't exist. There isn't anything. Some classes will just tell you to write no slope. I don't particularly like that because saying no slope kind of implies 0 as well, and I don't like that. But saying it's undefined means that finding it would blow a hole in the universe. We can't do that. Don't blow a hole in the universe, guys. Never blow a hole in the universe. I've done it before. It's bad. You have to call Dr. Emmett Brown and get his DeLorean, and it's this whole thing. Cool. Well, I feel like despite the last couple of examples, you might have a decent grasp on slope now. So let's look at what else we got. Let's look at actually using this. You know, we've constantly been doing the slope stuff. How the heck do you use it? So with the slope-intercept formula, everything you need is available at a quick glance. You know, I've kind of told you that with the equation, we'll be able to eyeball it and just graph whatever we need to graph. So I've been stressing the rise over run thing, one, because that is conceptually what's happening, but you can actually think of the rise over run being the distance between any 2 major points on your graph, at least the ones that aren't, you know, weird, horrible fractions. You know, we're not going to try to graph 1/6 on our graph. But the B value, the Y-intercept, tells us a point on our graph right away. It's telling us where the line is crossing the axis. So that's a starting point. When you're playing around with the slope-intercept graphs, you start from your Y-intercept, and then every point on the graph is rise over run away from that point. So we got the general idea here. This is kind of an unnecessary slide. This is literally just, hey, solve for y equals. All right, we've done that a lot now, right? I think we're good there. But now it's all about graphing. Man, I should have had more examples on this. That's okay. We'll make up more examples as we go. We're going to end up doing more examples than just these 5. You might say, hey, why did you have so little actually instructing how to use it? Because it's easier to understand if you see it happening. This is best done in the notes. Okay. So what we're going to do is graph using our slope-intercept, right? So all of these, the first thing you have to do is solve for y equals. We want the y alone, right? Same as the other stuff. So we're going to subtract the 2x, and we're just going to subtract the 2x. And over here, we have the y left. And over here, we have negative 2x plus 2. And I don't expect you guys to have the formula memorized quite yet. So I'm going to rewrite it. So on all of these, once you have it in the y equals mx plus b formula, your m is the slope, and the b gives you the y value for the y-intercept. So this is where the line is intercepting the y-axis. So that's why we have a 0 here. So for this particular problem, our slope is -2, and our y-intercept is the point 0, 2. So what we're gonna do, gonna make a nice, neat, generic looking graph. We don't know what points we're gonna have or where they're gonna be. So we're gonna keep it kind of close to the axis for now. Get some marks on there for now. Okay. There's a random graph. I don't know what we're going to end up with. Let's see. So every one of these, when you're graphing with the slope and intercept, we're going to start from our y-intercept, right? Because this is, the slope is just describing to you how the line is kind of leaning, how it's sloping from point to point. But the y-intercept is the only point we know for sure on our graph. So if we have y equals -2x plus 2, we take that 2 and we're like, cool. That's a 2 on the y-axis. That's our y-intercept. Now, I did say that slope we have to think of as rise over run, but it's a little tricky when I don't have a fraction, right? I have -2. It's all well and good to say my slope is -2, but how do I use it? How can I understand how to use that? Well, the best way to do it, at least until you understand it a little better, put that over a 1. If you have an integer, just put it over 1. And then I like to just write rise and then run exactly where you think they'd go. So I have a -2 rise, 1 run. What does that mean? Well, that means that every point on my graph is -2 over 1 away from each other. So for all of these, you write down your y-intercept, put it on the graph, and then look at your slope. Rise is -2. Okay, so from that point, we're going to rise -2. Well, if I'm rising -2, that means I'm going down, right? So I'm going down 2. That's my change in my vertical. And then my run is 1. So we'll go 1 in the extra positive x. Cool. Once you've done both, draw a point. Do this as many times as you feel you need to. I could go down 2 and over 1 again. I could keep doing it. I could keep doing it. I could keep doing this all day. How long did it take us to do 3 points earlier? in the last class. It took a while, right? Every one of them we had to plug in, we had to solve. We just found 5. But hey, what happens if, this doesn't just exist on our positive X, right? What's happening over here? Well, you can kind of see it's going to end up going the other direction too, right? So you can remember how I said that the negative can bounce around wherever you need it to? I can say that -2/1 is exactly the same as 2 over a -1, right? It's the same thing. Using that concept, I can go backwards. I can rise 2, I can run -1. It's cheap, but it works. I can go backwards from this. Up 2, back 1, up 2, back 1. We got 8 points. Did I need to get 8 points? No, not at all. I could have just done 2 or 3. I didn't need to do all those. But I wanted to show you guys that that's how long that takes. Don't worry, we're going to do plenty of them. I don't expect anybody to wrap their head around that perfectly the first time. So let's look at number 2. Number 2 is written nicely for us. Number 2 is y equals 3x minus 2. This one's already set up in our slope-intercept form, right? This one is already y equals, has the x coming first. So I can tell that my slope is 3 and my y-intercept is the point 0, -2. Okay. Let's do the same thing. Random graph. I'm starting in the negatives, so I want to have a little bit in the negatives here. Now, my slope, you might not have noticed this quite so well yet, because we've only graphed 1 so far, but this slope is negative. Well, if you have a negative slope, if something's sloping negatively, that means it's going to slope downwards, right? And from left to right, that's what's happening. This guy's sloping downwards. Well, in this case, we have a 3. It's a positive number. So that means this slope is going to move in a positive direction. It could be gradual, could kind of look like that, or it could be very steep and kind of look like that. Trick way of doing it's probably going to look about like that. About like that, because it's going to think about what this thing would look like over a 1. 3 over 1. Rise over run. It's going up 3 for every 1 run. So it's a little bit more steep than this guy. All right. Well, that we can do. That we can do. I don't know how many points I need. I'm just going to do that. Is that hideous? Oh, you betcha. So my y-intercept is 0, -2. So we're going to be starting at the point 0, -2. My slope is 3, which for now we're going to look at as a fraction. It's 3 over 1. So rise 3, run 1 from that point. So from this point, up 3, 1, 2, 3, run 1, and there we go. Do it again. From that point, rise 3, run 1. 1, 2, 3, run 1. There we go. There's another point. That certainly looks like a straight line to me. There we go. We're good. Any questions on these so far? They're not too bad, but learning it's really tricky if you're not watching or paying attention. Probably already figured that one out, right? Well, let's do more. I like the idea of doing more. Yeah, this will work. Number 3 is y equals 2x minus 3. So it's very similar to our last one. The numbers are just kind of switched around. So you can kind of tell it's probably going to look pretty similar to that one, right? In this case, our slope right here is 2. And for now, yeah, we know we're going to use this for graphing. So let's put it over a 1. And we'll write rise over run next to it. So we remember what we're doing when we're graphing it. That's one of those things where if you don't need it, you don't need it. So I'm going to do it just in case you do. Our y-intercept is the point 0, comma, whatever our constant term is. In this case, it's a -3. That would be our b. Y equals mx plus b, right? Even if my pen doesn't like to write. Okay. So we're going to do the same thing. Random graph. We have a positive slope, so it's going to be moving upwards. So I'm not going to worry too much about anything in the negatives other than that y-intercept. Or y-intercept's 0, -3. I can tell that that's the main point I'm after. Everything else is going to move upwards from there. So I'm cool with just bottoming out at that point. Let's do a little bit more points. Doesn't matter how many, because we're only going to do a few, right? So our rise over run is 2 over 1. So we're going to rise 2 from our intercept up 2, right? So we'll be here and then run 1. Okay, same idea. Up 2 over 1. You can do this as many times as you need to. Up 2 over 1. I did a 4th just so I could kind of see. Sometimes I do a bunch of them just because my graphs are awful. And actually this particular method, if you know, you've seen my weird wobbly looking graphs. If I happen to make my scale wrong or my line a little crooked or something, then my actual equation graph is going to be like perfectly, I guess I'll say perfectly wobbled along with it. So any data I need would still be there because it's accurate between each point. So the more points I draw, the more accurate the graph I just drew is, right? Unless I'm using graph paper and a ruler, at which point everything I said there was just pointless. I could just do 2 points and use it. I'm just doing a bunch of points because honestly, my graphs are awful. Okay. Number 4, we have y is equal to -1/2 x plus 2. Okay. Well, again, this one's already in our correct format. We like that. That's convenient. Our slope is that -1/2. And our y-intercept is the point 0, comma 2. Some teachers will absolutely let you get away with just saying your y-intercept is 2 by just looking at this guy. Technically, this method is more correct. So that's the way I'm going, just to make sure you guys are, squared away nicely and understand it a little better. Now, this one's not bad. It's got a negative slope, so it's going to be sloping downwards from this point, right? So I'm going to kind of make a graph. I might end up extending this out a little bit. I'm not sure. We'll just make it kind of rough real quick for now. But the thing that might stop you dead in your tracks is, what do I do with a negative 1/2? Because the 1/2 is fine, but what about the negative? That negative is outside. With the whole rise over run thing, what do I do with it? Well, remember how I said that all 3 of those fractions with 1 negative in them were equivalent? This guy right here is exactly the same as this, and it's exactly the same as that. It could be a -1/2, or it could be a 1/2. What I usually recommend for people, remember, we're going to do rise over run. I'm not going to put that next to any particular one of these guys, just writing that down so we remember. Generally, what you want to do is probably pick one of these. That negative's got to go either to the top or bottom. It doesn't matter which one of these you work with, but we're going to pick one of them. We're not going to leave it like this, because that could cause us some issues, right? So let's say I roll with this middle one. Let's say I run with the -1/2. That way, between all of my points, I would be going a rise of -1, which would be down 1, and a run of 2, so over 2. So every one of these, I would go down 1 over 2. So from our point, from our y-intercept, down 1 over 2. There we go. There's our first point, past our first point. You know what I mean. It's our second point, but our first one with the slope. And you can do this so many times as you need to. Down 1 over 2. I could keep going if I needed to. Doesn't matter. It'll work forever. And you'll notice what would have happened if I had actually gone with the other option. This one would have been rising 1, so up 1, and then run -2. This one would have been up 1 and back 2. And that would have worked out fine. Would have worked out fine. Either way, once you have a couple of points and you're pretty confident that this is what you were after, draw a line between them, and you're good. Oh man, we are totally gonna end up hitting that 2D shapes thing tonight. All right. Let's do more. Let's do another. I'm just gonna say it now. If you want to see more examples past this one right here, because I'm planning on at least doing 1 or 2 more. But if you're not feeling great on it, you're feeling a little shaky, let me know in the chat, speak up, whatever you want to do. Just let me know. Let me know you need to see more of these. At the very least for now, this one isn't in the formula we need. We need the y equals. So we're going to get it. Let's subtract off the 3x. We get 6y is equal to negative 3x plus 18. Luckily, we're going to divide everything by that 6 over here on the left, because otherwise I do not want to graph anything with a plus 18 on it. I don't want to deal with that. So divide everything by 6. We'll have y, oh, come on, pen. Y is equal to, this will reduce. I'm going to leave that negative on top because, you know, that's just convenient for us. Negative 1/2 plus 3. Oh, with an X on it. Interesting. This has the exact same slope as our last one, but a different y-intercept. We have that same m is negative 1/2, but our y-intercept is the point 0,3 instead of the point 0,2. Well, it's going to change what our graph looks like, but not by a huge margin, right? So we're still going to start at 0,3. Is literally how I graph on my own, is I draw the graph as I'm going. It's a little ridiculous, but this is actually how I do it. So I needed that point, 0,3. And then my slope is negative 1/2, so it's going to go down 1 and over 2, just like the last problem. So I know I'm going to need some points in this direction. That'll buy me 3 of them. So it's going over 2 every time. So we're going to go down 1 over 2, down 1 over 2, and down 1 over 2. This can happen over and over and over again. Draw a nice smooth line between them, and we're done. So let's look at both of these graphs next to each other real quick. It's pretty much the same line, right? It's got the same slope, but it has a different y-intercept. I mean, heck, if I decided to graph these on the same setup, I would have one going through like this and the other one going through like that, right? Because one of them goes through 2 and one of them goes through 3, but they have the same slope. Well, what ends up happening is that means that these 2 equations were parallel. Do we need to know that right now? But that's very convenient to use because you've looked at parallel lines at some point in your life, right? 2 parallel lines are going along each other and they don't cross, right? Parallel lines just never cross each other. But now we actually have a way to prove it. When are these guys not going to cross each other? When they have the exact same slope. They're moving at the same rate, but they cross a different point, cross through different points. So they're never going to cross each other. So that's just kind of useful to know, yeah? All right. Let's do a couple more. It's probably starting to seep into your brain. I don't have any more particular ones like this prepared. So what I'm going to do, I'm going to go back to my find the slope examples. We had that 2x plus 3y equals 6. Let's graph it. I like that one. That one's nice. Yeah. So I would end up wanting to solve for y. So I'm going to subtract the 2x off. I get 3y is equal to negative 2x plus 6. And then I'm going to divide by that 3 on every individual term. And there's that beautiful y equals negative 2/3 x plus 2 again. Now notice I wrote this a little differently this time. Last time I put the parenthesis or put the negative on the outside. This time I could tell I was going to end up wanting that negative to stay on either the top or the bottom. So what I did was I just left, it was already on that negative 2 right there that we subtracted over. So I just kind of left it on that piece. Right? So now we can recognize our slope is negative 2/3. And our y-intercept is the point 0, that 2. Okay. So we're starting at a positive 2, and we have a negative slope. So this one's going to kind of go down from there. All right. Let's draw a graph. I'm going to do some points here. Okay. Okay. All right. So my y-intercept was 0, 2. So that's 2 on the y-axis. Just jump straight to that 2. Okay. My slope is negative 2/3. Remember, rise over run, so we're going to be going down 2 and over 3 between all of our points. So we're going to start from our y-intercept. We're going to go down 2 and over 3. Draw a dot. Then from that point, we'll do the exact same thing, down 2, over 3. And you do this however many times you're comfortable. I'm feeling pretty comfortable with that. I got 3 points. They look pretty straight. There we go. It's a solid line. It's a good line. Yeah. I'm liking it. Cool. Trying to think of a good setup here. You know, it would be a good example. Y equals X. That's a good example. It's actually the easiest one we could possibly do, but if you haven't done it and you haven't done a lot of these, it's probably the weirdest looking too. Oh yeah, Y equals X. What the hell am I supposed to do with that, right? Well, remember our formula, Y equals mx plus b. What do we know about our formula? Whatever's attached to the x is our slope. Whatever the B is our y-intercept. So in this particular case, let's kind of look at this. We don't need to actually do this if we're doing this on like a homework or test or something. This is just a step for you guys' benefit. Let's look at our equation. I'm leaving a little gap here. And say, well, how many x's do I have? There's an x there, right? So it's just one. I have one x there. Okay. Well, we could say the coefficient, that's the term for the number attached to a variable. Coefficient of x is 1. Okay, well, what about b? Well, we kind of covered that earlier, right? When I had that y equals 1/6 x, I believe we worked on. If you don't have anything there, then you don't have anything there. There's nothing there, right? This is just 0. So if I have y equals x, I'm going to rewrite that just for the fact that this is the piece I should be looking at this point. If I wanted to say what my slope is, I would say, oh, how many x's do I got? 1. Cool, that's my slope. And then what's my y-intercept? Well, it's the point 0, comma, whatever our b is. Well, I don't have a b. Okay, then I don't have a b. It's 0. Oh, so I have a slope of 1, and my y-intercept is 0. Well, y-intercept being 0 is great because that's just right there. That's the origin. So this thing crosses through the origin and it has a slope of 1. All right. Okay. So crossing the origin is easy enough to do, right? But what do I do with a slope of 1? Well, same thing I do with every other one of these that's an integer. Every one of these that's been just a solid number, I put it over a 1, right? This is no different. If I put this over a 1, I can more clearly see that I'm going to go up 1 and over 1 every single time. From our y-intercept, up 1 over 1, up 1 over 1, up 1 over 1, etc. What ends up happening? Well, we have a perfect diagonal line right through our coordinate plane. Perfect diagonal line. This is something that tends to pop up not infrequently, I guess you could say. I've seen this graph a lot. It comes in handy. When you get to really confusing stuff, some things will mirror across the y equals x. We don't want to play with that for a very long time. Hint, never in this class. But yeah, it's useful. Wait till someday you're graphing x cubed and you have to draw the graph of the inverse of it. You end up being like, oh man, I have to graph this over. It reflects across y equals x. This must be what that one weirdo that talked about this for years ago said. You know, if this for some reason sticks in your brain. So how are we feeling so far about graphing with slope and intercept? Is everybody feeling a little better? Feeling okay on these? Feeling it okay? Anybody need to see any more? Oh, sorry, I couldn't hear you. What was that?
Yeah, we can, if you can write in a little more.
No problem.
Thank you.
I knew somebody was gonna say it. That's why I left room for another one right there. All right. Well, what do I got? What do I got to play with? I don't like any of my previous examples. Let's pull some stuff out of thin air. Let's do y equals, why not 2/5? Let's do 2/5 x minus 3. I like that. That works. That's a good one. It's beautiful. Gonna be a long boy. As in graph wise, it's gonna be kind of longish. So we have a positive slope and a negative y-intercept. So we can kind of tell it's probably going to be starting down here and kind of going, yeah, a little gradual. It's going up 2/5 to each point, right? So it's going to be pretty not steep. What's the word for not steep? Is there a word for not steep? English is stupid. Why do we have this language? All right. Just an amalgamation of every vaguely Englishy sounding Latin language. It's terrible. It's terrible. Everything should be like Spanish. You know, guess what this letter sounds like? The same in every word. Then you have actors like Sean Bean. I know people who call him Scene Bean because, I mean, it's spelled the same. Scene Bean. Okay, that's my little rant of the moment. God knows I'm easily distracted. All right. So our slope is 2/5 and our y-intercept is the point 0, -3. So we just take those 2 bits of information out of our equation. And we can just throw these at the graph already, right? The slope is rise over run. So we know that we're going to be rising 2 and running 5. So we can tell if I'm running 5 between my points, I probably want at least 10 points on my graph on the horizontal, right? So let's do, my y-intercept is 0, -3. And then I want my graph to hopefully not look like garbage. Oh, but it's already garbage. Oh, it's already garbage, whatever. Okay. All right, so we start from our y-intercept and we move away from it to the next point in terms of the slope. So our slope is 2/5, so our rise is 2, our run is 5. So we're going to go up 2 and over 5 between all of our points. So we start here, we go up 2, and then we go over 5. Same thing happens again. I'm going to go up 2, over 5. All right. There we go. Not bad, not bad. All right. Let's do some more. Let's do another random example. I kind of piece this out as I'm thinking about it. Want that to be, yeah, I'll just leave that as an X. And let's do 6 plus 2y is equal to X. I like that. That'll work out nicely. All right. This is the moment when I realize there's brightness controls on this. Okay. So, just like every other problem we've done for these, we need it to be in the y equals, right? We got to solve it for y. So, I'm going to subtract the 6 first. We have 2y is equal to x minus 6. And then I'll have to divide every single term by the 2 to get the y alone. Divide that by 2, divide that by 2, and then divide that by 2. So we'll have y equals, now on the x, I don't really feel like writing x over 2, right? We want this to be y equals something x, right? So the x we want outside. So what we're going to do is we're going to, again, kind of think of that as being like a 1 there. So we're going to have a 1/2 x minus 3. So we got the 6 over to 2 there. Okay. All right, well, there's our equation. We have our slope is 1/2, and our y-intercept is again 0, -3. So the same y-intercept as last time. No, that wasn't intentional. Okay. So and set up our graph. Now, one thing I will point out is you guys probably noticed that I have a rough idea of what my graph is going to look like. So sometimes I'll make it a little wider, sometimes I'll make it a little taller, and you're probably just accepting, well, he knows what he's doing. Kind of knows what he's doing. So you might just kind of follow that, but why am I doing it that way? Why am I making this one wider than taller? Well, the reason is because I looked at my slope and I saw that I had a 1/2, which means that my rise is smaller than my run. My run is bigger. So because this guy ends up having a larger number on the bottom of our slope, I can tell that I'm actually going to end up moving to the right quicker than I am going to be moving up or down, depending on the case. Now, if it was different, if I had a higher number on top, like a 3/2 or something, then I could tell, oh, well, I'm going to be moving up quicker than sideways. So I would have a taller graph. So what ends up happening is, as long as this slope ends up being under a 1, so like under like 4/4 or 5/5 or something like that, then it ends up kind of being more gradual. If it ends up being over a 1, then it's a lot more steep. It moves up a lot quicker. But what happens at 1? Well, that was that diagonal one we did earlier, y equals x. So just random side notes. For now, just stick with what we know. We know where the y-intercept is. We know our slope is 1/2. So we're gonna go up 1 and over 2. Up 1 over 2, up 1 over 2, up 1 over 2. There we go. I got 4 points that quickly. Okay. Not bad. Not bad at all. So let's do one more example. And then we'll take a break right afterwards and move on to the next subject. So next one, let's do something similar to what I just said. I have a negative 3/2 x plus 5. Okay. Well, that's not bad. We've done these a lot. We can see that our slope is negative 3 over 2. And for the purposes of kind of moving up or down and to the left, I'm just going to have that negative on top. You'll probably end up, if you have to do these for a lesson or on a test or something, you'll end up finding that a lot of times it's just easier to cram that guy up top because you're usually going left to right, and that's going to keep it going that way. And then our y-intercept is the point 0, comma, we got a 5. So there's the 5. Okay. So the same thing's going to happen. Same exact thing's going to happen. We start from where our y-intercept is, and we move up into the side or down into the side based on our slope. That's exactly what we're going to do. So I can see I got a negative slope. So I'm just going to kind of go up to that 5. I'm going to call it good from there because I know I got a negative slope. It means it's going to go down from that point. So I don't really need to do anything higher. Okay. All right. Well, same thing as always. My y-intercept is 0.5, which I already got. My slope is negative 3 over 2. So I'm going to go down 3 and over 2. 2, 3 over 2. 1, 2, 3 over 2. You can see I clearly overshot what I was going to need on this graph. I don't know what's going on with this graph. I don't need any of that. I don't need any of that either. There we go. Now it's neat. It's neat and tidy. Look at that. All right. Got 3 points. I'm going to draw a line between them. And we are good. We are good. So hopefully we're feeling a little better on those. For the time being, I think we're going to go ahead and take a break. I've been talking for almost 2 hours now. I'm tired of it. I know you are all tired of me talking. If I am, you are. So I figure that I'll leave this up on the screen if you guys are still writing things down. And I'll write that we're going to take a break until 8 p.m. If you need anything else, well, I'm probably going to take a walk. I'm not going to lie. I won't be here. But you can message me and I'll check it.
I wouldn't do the same thing, right?
It's a good plan, man. That's a good plan. It's happiness. All right. Everybody's refreshed and breathing and hopefully stepped away from math for 10 minutes. Because otherwise your brain's going to explode doing this much math all at once. Well, don't worry, we're going to do more. This one's quite useful. So this is actually going to be how we find the equation of a line given some pieces of information about it. So say you're given a slope of -4 and a point -1, -6, and have to find an equation. Well, look at your standard formula. Y equals mx plus b. There are 4 variables there, right? We have y, we have m, we have x, and we have b. The whole thing is variables. Those are all things we don't know. But if you look at what we're given the slope, which is m, and a point. Well, a point is an x and a y. So we're given an m, an x, and a y when our equation needs y, m, x, and b. The only one we're missing is b. So if you have all but one of your variables in a formula, you can plug in everything and find that missing variable. So in this case, you could take all of those and plug them in and get it. Real easy, real easy. Do I have that as an actual example? Close. Now I definitely do because I'm going to put a minus there. There we go. Yeah, there we go. Okay. So that's really, it's like there's nothing else I could tell you about that except for us working through it. Kind of like the slope and the intercept and everything. But you guys will get it. You're a smart group. I like you guys. Yeah. Party. Number 1, we have slope m equals -4, and it passes through the point -1, -6. Okay. So, real quick, let's review what our formula is and how we have an equation. So our formula, again, y equals mx plus b. And the things we need to actually make an equation of a line is we need to have something there are m and there are b, right? The x and the y, those stay the same regardless when we have our formula. Right now we don't. Right now we got to make one. So if we look at what we have the m already, right? The only thing we're missing is the b. We need to know where our y-intercept is. But we don't have that. We have this weird -1, -6 point. So, you know, there's the origin and we'd be like back down here, you know? we're a ways away from wherever our intercept is. But we can find it. We can find it. Now, this isn't my favorite method of doing this. There's normally another formula, but for the interest of making your lives not a living hell, I don't think I'm going to teach you guys the other formula. If you get to that point at some point in your classes, cool. If not, actually, this is a method that that a lot of teachers prefer. I just happen to not be one of them. So the method is just using this formula, not learning anything new, not like I'm going to give you a weird looking hint. This is the formula I am not going to teach you tonight. If you're feeling morbidly curious and you want to know what this is the point slope formula. That is the proper way of doing these. For that formula, you can throw in any slope and any point and get your equation. It just takes some algebra. Now, the way we're going to do it for now is we're going to ignore that. We're going to actually take our original slope-intercept. We're going to take our slope-intercept. And what we're going to do is we're going to treat it as if, because this other formula treats the first y and the first x as being permanently a y and an x. You never swap anything out of those. But what we're going to do is we're going to look at our slope and intercept formula, and we're going to look at those y and x's that are normally so rigid. Normally we have them there set in stone, blah, blah, blah. And we're going to use those as variables. Now, that's actually a lot simpler than you're probably thinking it is. The idea is that we have our m, we have a point, and what's a point? Well, it's an x and a y value, right? Well, we have those variables. So what we're going to do, this y is going to become this y. We have a -6 equals m. We have our m. That's a -4. X. We have an x. We have a -1. I'm going to put that in parentheses, so you can see the multiplication happening there. Plus b. We don't have a b. That's actually what we're missing, right? So by doing this, what we're doing is kind of bypassing this formula. We're bypassing the proper way to do it and just being able to work it out, no problem. We end up solving just for b, and then we just have to go back and put it in, and then we're done. So it works out pretty well. So for this particular problem, we have a -4 times a -1, that's +4, plus b. We're solving for b, of course, so I'm going to subtract off the 4. We have -10 is equal to b. And again, what do we need for a formula? An m and a b. What do we got? We started with our m, we now have our b. So we're going to take these two pieces of information and we're just going to plug them into the slope-intercept formula. So we're going to have y is equal to m, which is -4, x, and then plus b, our b is a -10. So we're just going to have -10 right there. So finding an equation of something is really a lot simpler than you would expect, because by skipping this method, all we end up doing is we take what information we have and we're plugging it into this formula. Now, that's not always going to work. That's going to work when we have a slope, when we're already given the slope, right? Then we have an X and a Y, and we can just throw it at the formula. No problem. But let's look at number 2 real quick. Number 2 says we're looking for the equation of a line that passes through the points -2, 4 and 1, 2. That's all the information we have. We are looking for the equation of a line that connects these 2 points. Again, what do we need? We need a slope. We need a y-intercept. We just figured out in order to find the y-intercept, we need a slope and a point. We already got a point. We got 2 of them, whatever there. But we need to know what the slope is, right? Well, we've done this. We've found the slope between 2 points. That's the whole y2 minus y1 over x2 minus x1 thing. I know it sounds like it's forever, but it's only 2 hours ago. Why did I rewrite the formula? Because probably most of you forgot it by now, trying to cram all the new information into your heads. You ever have a math teacher that just does not understand that the more stuff you're learning, the more you're likely to not understand 2 + 3 while you're doing it? Like, come on, man, don't skip steps. I hate it when people skip steps. I will never skip an important step, not once. Okay, while I'm teaching it to somebody. While I'm doing it myself, I will skip steps like a madman. I don't even care. Okay. Well, we've done this, right? Again, we can label points just like we did earlier. We can do y2 minus y1, 2 minus 4, over x2 minus x1, 1 minus a -2. Of course, that -2 going into parentheses, so I don't lose the sign. The minus and negative will become a plus. I'm writing it next to it, so I don't have to write it as a full new step. I don't want to write it that way, neither do you. So that's what we're doing. And now we just got to clean it up. We have 2 minus 4 on top. That's a -2. Over, we have a 1 plus 2 on the bottom, 3. -2/3. That's nice, right? Well, now all we need is the y-intercept. We have our slope, we need the y-intercept. Well, we would find that the same way we did on this last problem. The last problem, we used y = mx plus b. We swapped out our slope, which we now have, and and our point, which is an x and a y, and we solved for b. But now we got 2 points. Oh my God, what do I do? How would I pick which point? Oh my God, how would I pick? You know how you pick? Either one is going to give you the exact same answer, believe it or not. Either one. However, which one do you want to pick? The one that's going to suck the least to plug in. This second point right here, this 1, 2, that has no negatives and the numbers are nice and small and neat, right? That's definitely the one I want to pick. That's not to say it wouldn't work fine if I picked this one. It worked perfectly fine. I just don't want to. I just don't want to. Okay. So let's go ahead and plug that in. We have, I'm going to rewrite it. just so you see what I'm doing, I'm just going to take our formula and I'm going to plug in what we know. So we have our y, which is a 2, equals m, -2/3, x, which is a 1. Whew, lucked out on that one. Plus b, which we have no idea. So we have 2 is equal to -2/3 times 1 plus b. Cleaning it up a little bit, guess what that thing times 1 is? Oh my God, it's -2/3 still. What a surprise. Now the annoying thing is I have to add 2/3 to both sides. So I have to add the 2 with the 2/3. Now, normally we would end up having to do a lot of steps to get this 2 to have a common denominator of 3. What I usually do is I usually have like a margin of notes. This whole weird empty space that I tend to avoid is my scratch area. I have 2 plus 2/3. I want that 2 to have the common denominator of 3. So I'm going to put it over 1, multiply it by 3 over 3, and I get 6 over 3. That's just a piece of what we got. So I can look at this and say, oh, well, this 2 plus 2/3 is actually 6/3 plus 2/3. So I can actually just, if I do it this way, if I have a little margin area or a scratch paper or something, I can jump to having 8/3. Because I know I'm adding 6/3 to it. Scratch area is your friend. Now, if I hadn't done that, I would have had to write it as a step. I would write 2 plus 2/3. Then I would do roughly this work right here over the course of 2 steps while I'm rewriting the whole equation the whole way down. And then I would put it together. I'd rather just do this off to the side. It works nicely. That's a Ben method. So we got our b, we got our slope. That's all we need for our equation. So we have y is equal to our slope, -2/3, x plus b, which is 8/3. And we are done. Luckily, we're not graphing that one because that 8/3 would cause us a lot of problems. If somebody, put a gun to my head and say, graph that. If I had to graph this equation, even though the slope and intercept are my favorite ways of doing things, I would probably multiply it through by 3 and start plugging in points. I would probably plug in points for something like this because if it's ugly and it's weird looking, plugging in points is a safe bet. It's always a safe bet. So we might be doing graphing with an easy way of doing it right now, but the plugging in points isn't something that you learned previously that was useful shortly and that you can discard. It is something that will stay useful. That is a good skill. Okay. Got another 10 minutes. Let's do another. I don't know if we got time for both of the other two, but no problem. Okay, so number 3 just gives us these 2 points and we're finding the line connecting. Same idea as the last problem. So an easy way to keep in mind what we need to do on these, we always need to find the slope first. And then find our B, which is our Y-intercept. I can't think of a scenario where finding the Y-intercept would be easier to start with than to end with. I'm not saying that for sure, because I'm sure somebody out there could prove me wrong very quickly. But for the purposes of what we're doing, finding the slope first is always going to be a safe bet. So I'm going to call this X1 and Y1, X2, Y2. I'm going to rewrite my slope equation so you guys can see it, follow along from it. So we're finding the difference in the Y's over the difference in the X's. So I'll have a -8 minus a 0 on top. And then I'll have a 0 minus a 5 on the bottom. Then we just clean it up. Nice thing, we got zeros everywhere. It's very easy to clean up, right? So we'll have a -8 on top and we have a -5 on the bottom. They don't really reduce, but the negatives will cancel each other out. So this thing's just going to be an 8/5. So we got our slope. We got our slope. Now we've got to find what our Y-intercept is. So we're going to use the same method we have been. We're going to use that Y equals mx plus b formula. And we're going to swap out the Y, the M, and the X to solve for our B. And again, we have 2 points to choose from. Which one am I going to pick? The one that doesn't have a negative in it. Is that always a safe bet? Maybe. But by avoiding that negative number that we have on this one, that's just saving us from a little room of error. I don't want any error. I'm going to screw things up enough. Okay, so I'm going to pick the point 5, 0. So the Y value here is going to be a 0. So we have 0 equals our M, 8/5, times our X, which is 5. Oh, that works out really nicely. Plus B. We don't know our B, so there it is. I didn't expect this to work this nicely. The 5s just cancel. 0 equals 8 plus B. Solving for B, just subtract the 8 over. We get -8 is equal to B. All right. We got our slope. We got our Y-intercept. We can throw them together and have a line. We'll have Y equals our M, which is that 8/5, X plus B, or B is -8. So I don't feel like doing plus -8, just do -8. And there we go. And that's something you could graph. Granted, if I wanted to graph this, I probably would have put those 2 first points on a graph and drawn a line between them and called it good. But now we know how to make an equation. Let's do one more. What line connects the points 7, 3 and 6, -1? I don't know. We're gonna figure it out though. Exact same steps that we did last time, exact same. We're given 2 points, we find the slope. Doesn't matter which one's 0.1 and which one's 0.2. Why did I just label an X as a Y? I'm tired, you guys are tired, I'm tired. That's X2 and Y2. All right. So our slope, Y2 minus Y1. So we have -1 minus 3 over X2 minus X1, 6 minus 7. Look at all those minuses. It's a lot of minuses. All right. So we have -1 minus 3 on top. It's going to be a -4. On the bottom, we have 6 minus 7. That's a -1. -4 divided by a -1. We just have a 4. Well, that was a pretty quick slope, right? Not bad. Now we gotta find the y-intercept. So I'll plug it into our usual. I'm not really seeing a difference in which one of these points is going to be easier. I'm just going to pick the first one because it doesn't have any negatives, but it doesn't really matter. So this y, I'm going to swap out with the 3, equals m, which was 4, times x, which is a 7, plus b, which we have no idea. So we cleaned it up a little bit. 4 times 7 is 28. And I can subtract the 28 from both sides. We get a -25 is equal to b. Cool. So we got our slope, we got our y-intercept, we plug them into our formula. Y is equal to mx, so 4x, plus b, which is -25, so minus 25. And that's all we need. Y equals 4x minus 25. Yeah. So as for the next class, again, that's going to be our testing day. That's going to be Tuesday. So feel free to contact me and let me know if you can make it to the class. If you can't, we'll just prepare adequately. So far, the great list of people who have already contacted me is nobody has contacted me, not a single one of you. All right. So if you can, over the weekend, shoot me a message, let me know if you're going to come in person. If not, we can get the testing codes and what have you ready to contact you on Tuesday. After that, our last class will be Thursday. Depending on how Tuesday goes, we might have a little lesson, we might not. It just, we'll play it by ear, see how quickly it goes through. I might end up maybe halfway through the class period, once everybody's done with the testing, moving back into the usual room, starting up Zoom again, and having us a little mini lesson. Which sounds good to me because honestly, I don't know if we're gonna cover the rest of everything I've prepared at this rate.
Slides.
There is a lot of slides left. We're on slide number 12,
You have?
51.
Oh, wow.
So, yeah, there we go. Otherwise, you guys are done. I'll let you go. Have a good night. I'm gonna get these notes scanned and they'll be in the Google Drive by the end of the night.
So it's going to be this Tuesday?
Yeah, this coming Tuesday, so 5 days from now.
Okay, same time, huh?
Yep, exact same time. If not, then I'll be contacting Elizabeth over the weekend. Everybody will get an email on Monday if anything changes. If nothing changes, stay as planned, 6 o'clock, computer room or on Zoom, we'll figure it out.
Okay, thank you.
Have a good weekend.
Have a good one.